It's my first time at CppCon. I've thought about going for a lot of years and now kind of regretting that I didn't go sooner.
Thank you, everyone, for coming to join me for the last talk of Wednesday, and all of you that are watching online tomorrow for the rebroadcast. So I'm here to tell you a story about a project we had at iZotope where we were refactoring a legacy UI library, and we're able to take a lot of our runtime errors and turn them into compile time errors so that we would have a more productive workflow. So just tell you a little bit about myself. I'm Roth Michaels. I'm a principal software engineer at iZotope. My background was actually in music composition, and I got into software development specifically with the idea of thinking about how to make interfaces for particularly avant-garde music at the time, but in general, performance of music in general. So this is, I think about UIs has been something I've been thinking about long before I was at iZotope. And so for those of you probably who might not have heard of who iZotope is, we're a software company making software for audio production. So that's both for cleanup audio for film and television, as well as mixing and mastering of records. And most of the software that we're using is running in real time and inside of some other host process by some other vendor, whether that's some other audio editor or video editor. And that presents some of the challenges that we'll discuss and kind of motivations for why we made some of the choices in developing our own UI frameworks. So today we're going to talk just about a little piece of our in-house UI framework that we call the GlassProperties system. And this is the story I'm going to tell about how we made this legacy runtime system compile time safe. There's going to be a bunch of code examples I'm going to show, and I might move through some of them pretty quickly, because the main story here is not to show you a whole bunch of C++, but to actually tell you the story and journey we went through to kind of diagnose the problems with our old APIs and how we found the solutions for the new APIs. And wanted to kind of give you all the details of kind of how we iterated through that, so you can kind of look back through some examples. And we'll pause at the more interesting kind of templates and techniques that come up and how we kind of use some of the more fancy C++ 17 features. That being said, if you get lost on the way on this journey, feel free to raise your hand and stop me for a question. If I can answer it then, I will, or we might parking lot it. And for those watching online, I'll do my best to do that live in the chat. So what do I mean when I say a property system? It's a way of taking an object and synthesizing member storage, synthesizing getters and setters, and having automatic change notifications so the object knows when one of these getters or setters have changed and could respond to it, like saying, oh, my background color changed, I need to repaint myself. And then as well, the ability to serialize and deserialize these properties into strings so we can save them in other textual formats. And this is something not unique to our project. This is what a property system might look like in Objective-C, declaring a text property and a background color property. Similar example in Swift. And this is where we're going. So by the end of this journey, we're going to have something like this where we can make a declaration of GlassProperties and declare these button properties. And we have these 4 properties: text, background color, which I call BG color for slide space, border color, and border width. And then we can just apply these to a button by inheriting from this has properties mix-in, where we supply the button class that we're applying the properties to, and this button properties list, which is actually synthesized under the hood in that macro, but we'll save that. You'll see how that comes in a little bit. And the way we would, and one other note, I'm using k as a prefix for constants here. So if you see a k something, that's just some constant defined somewhere that the actual value doesn't matter. So these are clearly constant colors, blue and black. You'll see some other constant strings show up. The definitions of them don't actually matter for the examples. And so this is how we would use these properties. You might make some button widget, and then you can just call set property templated on text if you want to set some text on the button to say hello, or we can template on BG color to set the background to blue. And the way this works is the property type that we've set up has a corresponding actual value type. So the text is going to be allows you to set that with a string, and the background and border color will allow you to set those with colors. And here's how getting properties might look. In some draw function, you might have a fill box, draw box, and draw text that do some stuff. This get bounds is just getting the size of the thing. And we can get the background color, border width, border color, and return those values and use them as needed. And haven't had any to worry about actually declaring any of the members or anything like that. So before I go on, I just want to tell you a little bit about why this is not just a crazy, not invented here story, but there's actually real reasons why, as a small company, we're developing our own UI frameworks. And that's because life as a plugin in someone else's application has a whole lot of challenges. And when I mentioned this kind of over drinks on the first night, someone mentioned, oh yeah, because you're a DLL and you have to worry about symbols clashing and all this. Yes, that's true, but in general, the host doesn't internal our symbols, so we don't really have to worry about that. We have libraries that deal with that, but there's plenty of other challenges. The main one is that, oh, actually, I'll just go back. In the background here, you might not be able to see it because it's kind of grayed out, but there's one of our plugins loaded up in a third-party audio host, Pro Tools, and you see one window there. And this is Neutron, our mixing plugin, but actually in real life, you could have 50 of those instantiated in a single session, all from the same DLL. So there's no shared state that we can like save globally, like for our UI, because the same UI could be instantiated many, many, many times. So that's one of the challenges, multiple instantiations within the host process, so we can't have global state. There's many ways we can get onto the screen. The host can make an OS window for us, and then we provide a view to go inside it. They can make the OS window and then give us a view to draw inside, or we can pop up our own OS windows for like a preset browser or something. Performance is, of course, a major concern. Lots of these UIs could be running at once. Metering needs to be high frame rate, and users need responsive control of their audio. And the threading model is nuts as well, where there's a bunch of both kind of things that might seem UI related or DSP functions, parameters, and the host application we're in could call us from any thread they want to. There's a couple restrictions, really not much rules, so we got to be prepared for that kind of stuff as well. So that's why when the company was founded, they did a little bit of experiments with Qt, but at the time that was not really viable to use in this sort of audio plugin context because there was a lot of global application state. So the founders started making their own UI framework because there wasn't really anything off the shelf available for plugins at the time. A few years later, there was this other platform that some of you might have heard of called Juice. There's actually a battery. It's not just UI. It's a batteries included framework for doing audio plugins or applications and on mobile. And if you're starting today, that's a great place to start. And actually, just quite a bit of the industry of audio plugins are made with Juice. The exponential audio reverbs that iZotope sells, those are from an acquired company that's made with Juice. And I know one of our researchers also likes to use it for prototyping. And then Qt is actually a viable option these days. Our sister company, Native Instruments, which is one of the biggest makers of virtual instruments and sample packs and that sort of stuff, switched from their own homegrown UI framework to Qt around 2014 and has been working with the Qt developers to kind of remove all those impediments to working in plugins. So Qt in general does work in plugins. Bugs show up. It bothers Native Instruments. They work it out with them. So Qt is potentially a viable option these days as well. So keeping in mind that our framework has existed since 2002 when this company was founded by a bunch of recent undergrads from MIT. I think there was 4 or 5 of them. 2002, they might have still been in the founder's mom's basement, or that might have been when they got the office, I'm not sure. But over the past 20 years, it has grown into an organic monster. And you might be asking, which one of these two beasts from the sea is the monster I'm talking about? Well, it's actually both, because there's 3 different epochs of this monster and different ways of using it that evolved over time. So there's probably some third sea monster you can't see about to eat all of them. And when I'm going to tell some of these horror stories, I want to just make sure everyone knows I'm not calling out any of my coworkers, founders, as being bad developers. As you can tell, it might be a little blurry. We're all smiling. We're all dressed the same, so we clearly like each other. But sometimes solving real business problems, you do pragmatic stuff. You make the API you need today, and it might not be the best thing for you 10 years from now. And want to point out, you might not see it, but that guy in the circle, if I'm teasing people, sometimes I'm teasing him because he made these mistakes, and that's me, if you can't tell. So yeah, what are we going to do about this organic monster? How about a rewrite? And that might sound pretty scary, doing a rewrite of a legacy library, but there's real reasons we did it. And actually, I think we took a tactic that led to a successful project that I want to share with you. So one of the reasons we wanted to keep it is we had a system for specifying layouts for our UIs in XML. So you can have a tree of child views and specify their properties all in XML. We also had oh man, sorry, I'm pushing the wrong buttons here, getting ahead. We also have a style sheets for applying property settings based on classes throughout the entire UI. It's JSON, and it's a little verbose and weird, but kind of very similar to what you might expect from a CSS style sheet. And we had this interactive editor that actually lets designers and developers both debug and then edit these layout files in a live running plugin in a host application. So we can actually see what changes the UI look like while we're actually feeding audio into the product and having metering. So we didn't want to lose these nice things we had in our development pipeline, but we had a lot of baggage that we wanted to deal with. And so we were looking for alternatives. And so we kind of looked at Juice, Qt, a number of other libraries. And one question that came up as well was, well, which string do we want in our code base? Because we had our own capital S string. I'm sorry, it's in the global namespace. That predated std string, I think. Qt has Q string, Juice has Juice string, and of course, standard library now has std string. And this was really not a major deciding factor, but that did come up in conversation, and it made us realize, do we really want to adopt another library that isn't super modern C++? Or do we want to take the technologies we like and upgrade them with new modern C++ APIs? So this std string conversation actually was one of the things that was the tipping point for that decision. And now I'll go to share another kind of lesson learned along the way. We initially called this project Canvas 2 because the original library was called Canvas, but that had a lot of baggage and people didn't really like working with Canvas. So rebranding. And so it's Glass, because that's what windows are made out of. And we even got, someone ordered some mascots on Etsy, and so everyone was in a good mood about the new project. And so how are we going to approach this rewrite without, having any of the horror stories that might come from rewriting a legacy library? And the answer is not actually rewrite it, but do what I call a porcelain rewrite, where we use the plumbing we have. This is kind of not the full tech stack, but just a little example. We have a bunch of third-party libraries. On the right, you see AGG, which is a rendering library, FreeType, libpng, and that and our other kind of shared libraries like IZBase and a whole bunch of other stuff that's not on this slide support Canvas, our old library. And so instead of doing a rewrite of that, we will keep Canvas as the underlying engine and add a new layer on top called Glass, where we'll pull in some new libraries that we wanted, like Yoga for a rendering engine, and Skia, Yoga is the layout engine, and Skia is the rendering engine from Google Chrome, and also a new thing, Sparkle Motion, which is a new rendering engine that gave us more high-performance meters than we had previously. And then we could actually split out one of those pieces of Glass into GlassProperties, which was the most disentangled part of it from all of our legacy libraries and the easiest to open source. So that'll be published shortly after this, as soon as I can get my git filter branch command to work right to apply the Apache license. But the link is at the end of the talk. And from Herb's talk, when he was talking about the two meanings of finish, this reminded me of another point to think about if you're approaching a project like this is you're finished if you want to finish. And by what that I mean is you don't want to kind of approach a product like this in isolation and then wait till it's done and say, okay, now let's use this in a product. Because you'll have to lobby for time to do that in addition to your other product work. And it will be seen as this kind of tech debt investment. But instead, if you actually anchor it with a project and don't deliver it all at once, but just one feature at a time as the kind of clients need, you can actually, have success and ship stuff actually right away before the thing is done. So, for example, when we were very early days, one of our plugins, Insight, got an update, and really all it got new was a layout engine. There was nothing else. Focal Doubler and Nectar start to use more of the new technologies with some rendering, etc. But this whole thing I'm talking about today, the properties, didn't exist yet. We were still kind of using the old system or just C++ getters and setters. And so we shipped 3 products. And then in between there, we then actually had the system available for a big UI rewrite in Neutron and some partial rewrites in some other products. And finally got to a brand new product, and everyone's loving using Glass. And even our most legacy product, RX, every time they update it, they're using little pieces of that. And again, new product, fun time working on NeoVerb. So these Canvas properties, Canvas, our old library, what was wrong with its property system? And I'll show you kind of an example of what it might look like in a button, and we'll kind of talk through some of the things that were not ideal about it. So first of all, you'll see that we have two classes here. One's kind of abbreviated. We have our button, which inherits from canvas view. I'm changing some names from what they are actually in the library, so it's less confusing for you because things were named strangely. And a canvas view is two things. It inherits from trackable, which is basically a special kind of token for managing callbacks and their lifetime. So if you want to register a callback for something, you can pass this trackable token, and that manages the lifetime of that callback. We'll kind of see how that works a little bit later. And then the other thing it inherits from is property holder. And this is what is the functionality that gives it the Canvas widget's properties. And it does that through kind of a simple API. You have a call, and it's all imperative programming to kind of create these properties. You can call create property, where you give it a name, a string for representing the type of property it is. So it might be int or color, and then a value, which is passed in as an any, because that's how the properties are internally stored. It's basically a map of strings to any's that we encode and decode to the right type. And then we have a get property API and a set property API. You'll notice that the get property returns an optional T, and then the set property and create return bool. This is because they could fail, because the user could screw up in certain ways. Like if you create property with a property type name that isn't something the system knows about, that could be a failure. You can't register the same name twice. And then same here with get property. If you ask for a name that doesn't exist, you'll get a failure. Or if you get the T wrong and you say, like, give me a background color, but you pass int as T, it will return an optional, because it's like, oh, you asked for this, but you don't know what type it is, so we're not going to give it to you. And so just kind of show you briefly how that, and same thing, set also will fail if it has a missing name or the value is of the wrong type of what's already being stored in that any when you created it. So just how that looks, an example from Git. If you look at the top part of it, the first thing we do is we just look through all our map of property values and say, okay, is there anything that matches this name? If we can't find it, then we just return null op because, oh, this property doesn't exist. You must have made a mistake. Then we see, okay, we found a property. Let's see if we can use anycast. Oh, this is leftover code because we're actually using boost any for historical reasons because we support some older Mac OS. But we use anycast to see, all right, is this value actually T? And if it's not, again, we return nothing. And if we made it that far, then we found the right name, it's the right type, we'll return the value to the valid optional. And set works the same way, where it will check the same two things before setting the value. We won't look at that example. There's also another API called get prop signal. It's actually get property signal, but shortened for the slides. And if you've seen either boost signal or the signals and slots in Qt, this is kind of a similar concept. This returns an object where you can register lambdas for a callback. And that signal object is also a functor that you can call with empty parentheses to fire off all of the lambdas. And we'll see some of that registration in a moment. And there's more APIs. There's some get serialized value and set serialized value that has to do with stuff with those layout files. As a C++ developer, you actually probably shouldn't touch those, but they're there, and so we definitely touch them from time to time for good reasons, but maybe confusing reasons. And the comment down there, the API surface of this is actually huge, and we're not going to talk about all of the various methods that existed on this property holder that were useful over time that we don't use often, but they're there if you want to mess with them and get weird, which is not ideal. Anyway, back to our button. So a button is this canvas view, which is a property holder. And the first thing we want to do to set up some properties is say, okay, what are their names? And so we can reference them elsewhere. Oh, I'm sorry, these should also say extern here, mistake in the slide. But, oh, actually, no, I'm not. I'm sorry, because they're static members. That's actually one of the other confusing points is people would kind of, different eras or different developers would declare different places exactly where their constants were. So you had to look around for all of that. So we declare the names for our constants. In our CPP file, we'll give all those constants names. And then in our button constructor, hopefully, again, developers could do that later in the lifetime or create these properties anytime they wanted. We'll actually create some properties. So you see, for our text property for the button, we're going to say create property templated on string, pass our key for the property name text, pass another key to tell us that it's a string property, and then a default value of an empty string. Similar thing for the background color, border color, and then an unsigned for the border width. And now you notice what I've highlighted in orange, we're kind of encoding two pieces of information twice. One is the actual type of the thing we're creating in C++, and the other is a constant that's a string name for that type. And you're expected to know that in our serialization system, k string prop is a std string, or k color prop is a color, and it's up to the developer to keep track of that information. So that's one of the downsides that we'll see that we're addressing. And then this is what it might look like to connect a property signal. The top example is a little more complex, so we'll gray that out for the moment. But if we look at our background color and border color property, when we set those, we're going to want to repaint because we now have a new color. And so in our system, we're using the method to repaint is called setNeedsDisplay. So we create a lambda called update that calls setNeedsDisplay on this, and we pass it in to these connect calls for get property signal. So we're getting the signal for background color, and then we call connect. By passing this, we're passing that trackable that we're inheriting from, that token to manage the lifetime of this lambda, and we're setting those two lambdas. It gets a little more interesting when we have more work to do. Imagine this example for the text. We might want to do some other stuff like get the current text, not just repaint, but we want to get the text value and ellipsize it if it's too long for our size or something like this. And one thing you'll note is when, remember, get property returns an optional, so we're going to call get property, get our text object, and then assert that text is true so that a developer might get a warning if they screwed up. And then we'll call setNeedsLayout because we might need to change the size of our button due to the text. We'll ellipsize the text, getting the text value or if it was empty, if we screwed up, because we're kind of this style at the time was, well, we'll warn you with the assert, but we'll kind of make sure you're not going to do any undefined behavior, and then call setNeedsDisplay. Now, that's not exactly how it's spelled in our legacy code base, because we weren't using optional at the time. I'm not sure if even boost optional existed at the time, but there's this thing we had checked value that essentially wraps up the assert and the value or. So this checked value type, when we pass it the text to ellipsize, if it is empty and an invalid checked value, it will assert and then just return a default constructed object. So you'll get an empty string in this case if you screwed up and passed Bob instead of ktext, for example. So that's kind of one of the areas that you can see. As I showed you before, you kind of have to manage these string types and actual C++ types. It's really easy to make a mistake and then silently not notice it because your default value could seem reasonable to you at first. The other thing I want to point out is this is another one of the challenges of working with real-time audio software is it's not always practical to actually be doing your development with a debug build. So you might not hit this assert. So for example, there was a piece of processing I was working on, something called the Ozone Spectral Shaper that is really heavy-duty processing. And I think in debug mode, I was getting about 30 or 50 milliseconds of audio per 2 seconds. And I was working with QA trying to listen to those chirps and figure out what was going wrong, and nope, I couldn't. So release build, and then actually did some UI stuff and actually made one of these mistakes missing this assert. So you might think, oh, well, if you want to know about this in release, why not throw an exception and just let it not get caught and bring stuff down? And normally in real-time audio code, you're not throwing exceptions, but maybe that's okay in the UI. The reason that doesn't work is most of the hosts that we run in have an exception handler around us in any call they make to us. And they'll just catch our exception and maybe just do nothing, ignore it, or in best case scenario, they'll shut down the audio engine and pop up an error saying one of your plugins is being crazy. Maybe we could do std terminate. Well, actually, some of the hosts also change the std terminate handler while you're in your plugin. So again, you can't bring the system down. You can just stop it from running, essentially. So unfortunately, there's not a whole lot of ways to get notifications out of that world when you're in the release build. And then one other thing I want to show you that's an easy mistake to make is this isn't from not enough room on the slide, but I have not set up the property signal for the border width. But we're going to need to redraw when that happens. So it was just missing. And that's a common mistake that can happen and not get noticed because when you set up some widget, you might set a whole bunch of properties. Like I want this text, I want this background, this border color, this width. And then as long as one of those requested a repaint, at the next draw loop, you'll get a repaint. But then later, a designer might come to my desk and say, hey, I'm using the interactive design tool and I change border width on its own and nothing happens. And I'll just say, okay, it's called border width, find that string, what's the constant, and then kind of search for it anywhere that constant is either being used or not used, which could be a lot more complicated example like this, where there's a class hierarchy, and you eventually find, oh, we had that, the thing was commented out, that just wasn't there, and that's what we were missing. So users failing to call the right update messages was a common source of errors. And the other downside was the actual types we could use was buried way down in some deep part of a library that nobody really looked at. We had this kind of very simple set of types. Most of them, but not all, had an optional version. And if you want to do something else, people would just kind of coerce one of these types into what they need. Like, just put it in a string, and then the widget itself will kind of figure out how to deal with it. And, that kind of made it a lot harder to reason about what was going on. So kind of in summary, the things that were wrong with this system that we didn't like was it's imperative. You have runtime type mismatches. All the kind of setup was done at runtime. These signals being public were confusing because anyone could actually connect to those signals. So it's not just telling if I'm some button, I might not be the only one that connects to those signals. Any one of you in the room could also connect and know when my background color changed and have some spooky action at the distance. And that's actually normal, like Objective-C properties do that, but we use it so rarely that it was a surprise anytime something like that was happening. So we kind of thought that was something we didn't want in the UI. I mentioned forgetting to repaint, and that system didn't encourage creating new types for the property system. So instead, we wanted something that was more declarative. We want to put all the information in one place because all those imperative function calls could be spread out throughout a class and kind of have to hunt around for stuff. And most importantly, we wanted to make it type safe and have compile time errors and only create these properties on construction. So I have an object, it now has all its properties, we're done. So how are we going to go about doing this? First thing I thought is, well, we could put all the information together maybe with some macro stuff, like maybe M4. If you haven't heard of that, maybe that's a good thing. It's what AutoTools uses. It's a crazy macro language. I've never used it for anything real, but I have a perverse desire to try it. But that's probably no good because we didn't want to use Qt because that also had its own preprocessor step and that was outside the tool chain. So we didn't want to add outside the tool chain stuff. So I thought, oh, maybe I can kind of collect the data in a macro, and depending how you define it, it either like does the constants or does the creations. And I mentioned this to someone, another principal engineer that sits across from me, and he said, yeah, please don't do that. So C++ 17 templates, that's got to be the answer, right? And so the things we're going to address, kind of the big two pain points we're going to look at with how we address this with a new templated API is this assert. Really should never come up. It's only going to come up if there's human error involved. But if you use your types right, you're going to get something out that's a valid optional. Also, there's a lot of work you have to do. Like, you have to basically say the same information twice and put it on yourself to get it right. Why are we doing the work for the machines? Why don't we just explain what a property is and have the compiler figure this all out for you? Part of this slide didn't load. Strange. Well, that's supposed to be a picture showing you that the property holder has these calls, set property and get property and create property that are all a T. And as long as you always use the same T, they're never going to get out of sync. And so if we can enforce the same T, things will be groovy. And then on the serialization side, we also know that basically anytime there's a mistake in something to deserialize, like, oh, maybe this thing doesn't have a filter control curve class name, or we typoed border, or the property type is nonsense, or the value is empty. Those will just fail at the serialization step and never even get to our object. So we don't have to worry about a style sheet somehow changing the type of the any out from under us. Oh, maybe this is actually what I want to show. So yeah, in the C++ side, these are the only methods we use to interact with property holder on the client side, or should be using. And so if we can enforce that T is always the same, this can be totally safe. And so how are we going to do this? Here's kind of a very basic example of a simple property where we are going to want to encode all the information for a property in a struct. So we have these button properties namespace, and we are going to have a text struct that's going to represent the text of our button. And it has a property type, which is stood string. It has a name, which is text, and it has a default value. And that's basically how you define a property, is you got to provide those three things: a type, name, a default value. You see, we have all of our information mostly in one place. And then we also have this one other special thing, is if we implement a didSet method that takes that property definition as a value, that will automatically get registered as a callback during the constructor. So we'll see how that works in a minute. And there's no more connecting signals. If you want to know something about your property, all you have to do is write a didSet, and it automatically will connect. When I said all the information's in one place, that's not exactly right. Because if you notice I say stood string here, how do I know how to, I mean, it's probably easy for string, but how do I know how to serialize or deserialize that? So we actually don't want to say the type directly, but we want to have some other struct that explains what the type is and how it gets serialized. And so we replace this with string property type, which would look like this. It has a type, which is stood string, and it has a name, which is stood string, and it has two methods: serialize, deserialize. For a string, that's obviously super simple. It's just, you're still a string. Little bit more complex example, just so you can see that, we do write real serialization methods. So for unsigned int property type, you see we have our types uint32t, our names uint, and our serialize is just using format to print it as a string. And then our deserialize, we use boost lexical cast to try to turn it into a uint. If that throws, we catch it and return null opt. So the deserialization could fail if you give it something bogus, and then we just won't do anything with that value. And having these a whole bunch of built-in types in a header with these serialize and deserialize right there makes it encouraging for other clients to see, oh yeah, here's how you define a new property type. I can do that. All I need to do is a using and write a deserialize and serialization function. And actually, at first, you can just have those be bogus functions, just like stubs, as long as you don't ever actually serialize them. So even while you're getting going, you can say, oh, I need one of these, and I'll figure out how to write my serializer later. Boost key, spelled, I think it's how you pronounce it, QI, is a really cool library to use for writing parsers. So that's how we did some of our more advanced serializers. And then you can actually, once you have this serialization property type, you can actually use that to compose and create new types. So before I said that some of the types in the old system were optional and some weren't. That was always a drag if I wanted an optional version of one of the ones that was not optional. Now we can actually just make any property an optional property by taking this. There's actually a little bit of a mistake here. This is supposed to inherit from T. I'm not going to edit it, but this optional property, its type is optional T. I'm sorry, this is not an exact, stay tuned at the end. I can show you the correct version of the slide. I'm now realizing this has a number of typos in it. But the main point is the name and the serialize, where we're essentially taking the name from the property type we got passed in, T, and prepending optional to it. So now it has a new name. So if this was templated on our string property type, this would now say optional string property type. And then for serialize and deserialize, or serialize, it's pretty easy. If the optional is valid, just call T's serialize function. If it's not, put a string out that says null opt. And deserialize is similar. Check if it's null opt. If it's not, use T's deserialize function. But you'll notice there's something a little bit strange here. On optional property, name's a function. But in the other examples I showed you, name was a constant member. But now if I were to compose an optional property, that's not going to work because tname is a function in that case, not just a string. So we want to deal with the possibility that names could be just a member, string-like thing, or could be a function returning a string-like thing. And so how do we deal with that? And this is going to be our first kind of template trick. So we want to replace this with a function called getName templated on T that's going to do the right thing for this T to get the name out for us. And here's what that looks like in modern C++. So it's a constexpr function that's going to return auto because it's whatever it needs, templated on this property type. And we're going to do it if constexpr is function tname. And we're saying, hey, is T a function? If so, call it and return that. If not, just return tname. And now, if this just showed you what this would look like, kind of a more old school way without if-const expr, you would write two functions and use phenai to kind of turn one or the other off. So the top one's uses enable ft if it is function and if not function. Don't worry about that example too much because this is the cool way to do it. And this is actually not specifically relying on, maybe the underscore v is C++17, but in general, I think this should be 14 and maybe 14 at least, you should be able to do this. And you might want one more feature in this get name, which is actually asserting that it has a name. So you get a kind of a nicer error message if somebody calls this on int or something ridiculous. And this is actually pretty simple to write. This has name is we create a type. This is the best kind of modern way to write a type trait that I've come up with. If you know of a cooler one, please let me know. I'm interested in seeing if I can beat this somehow. But essentially, we have a template on T, and ignore the second template parameter for a second. Our inline bool has name, and that defaults to false. And then we have a specialization that is true. And the way this works, if you haven't seen this before, is the second type parameter is void by default. In the specialization, the second type parameter is just void t with some other stuff inside. Void t is just a template t, void t equals void. So whatever you put in there, it doesn't matter. Void t is it's just void. So what happens is the default template parameter is void. So that means, oh, it's t void. That means we should use a specialization on the bottom. And then we try to we're using this specialization, and we try to substitute t name into the decal type. And that's because void wants you to pass a type there. So we're saying, what's the type of t name? And if there is a t name, and that's a valid template expansion, this specialization will exist, and it will equal true. If there is no t name, then that specialization will get removed with phenai, and then there is no specialization to jump to for the void, and we're back to the has name false. You may want to, if you don't like that second type parameter and think your users might do something weird and actually fill it in, because no one's actually supposed to change that default type name from void, you can wrap it up in a detail namespace and then have your outside the detail one on the bottom just templated on T so your users can't, see in their IDE autocomplete, oh, I can type some other type in here. We didn't do this in this case in this library because all of these type traits are just being used within the library itself. And of course, with Hiram's law, they could leak, but so far they haven't. And so just to reduce noise, I normally don't worry about that detail move and just have it like this. So you see with that, we get back to here and we can use get name, and it doesn't matter if it's a function or a member, and we'll get a nice error message if it doesn't have a name. So going back to our button, this is what it would look like to declare our 4 properties that I showed you earlier. Text property, string property type, text, empty string, doing a color property, background color, black, similar thing for border color. Border width is a uint, and noticing instead of using auto, I'm using property type there just to make sure that I'm narrowing to the correct thing for my constant so I'm not making a mistake. Kind of a style thing as you're working on it. It shows up both ways in our code base. And then the last thing that goes in this namespace is this using list equals property list. And here's where we collect all of the properties into a list. And this property list type, it's really simple. It's just an empty struct templated on a bunch of types. And so it's basically just our way of collecting a bunch of types into a list. And then that's what we pass into the has properties base class that provides all our property functionality. It's kind of the curiously recurring template pattern. We pass the derived class and then the list of properties it's supposed to have. And then you see our button. One property has a special did set method, but all the others have no did set because we actually want that set needs display to happen automatically for our users so they don't need to remember to get that attached to every single property. And so this is what our has properties looks like. we took what we used to inherit from a property holder, inherit from a trackable, we've now composed those, and so those are hidden away, and we can now start making a new API that is a little bit smaller and more what we would like. And that would just have a set property and get property. And you notice this time, there's no failure mode. Set property just returns void because we're going to expect for this API, it's always going to work. Same thing, get property is just going to actually return the type referenced by the property definition. It has a property type member that describes the property type. And then that has a type that's the actual concrete C++ type. And we can use these and be sure that we're going to be happy. And again, how this reminder from before, this is what it looks like at the call site. And so, to be clear, these specializations don't get stamped out anywhere like this, but just to show you kind of what's happening with all of the use of the T, property type. In the case of the set property, get property text, it returns string. Set property text takes a string value. Similar thing with background color, either returns a color or returns or set by a color. And you see now all these string identifiers are gone, and there's a tight coupling between the kind of name property BG color and that it is a color type. And at this point, this is another kind of lesson along the way of the design of this. The way I was building this out is first writing out what do I want it to be like to use, and then gathering a few heads around the office and being like, okay, how do we actually make it do this? So at this point, when I had this, it did not work or do anything yet. These were empty functions. It's like, okay, now let's figure out how to make it real. So we're first going to start with get property. And it's actually, the basics of it are pretty simple. The using type there, that's just to make this P property type a little bit smaller for the slides. And all we're doing is calling on our property holder, get property on the type, and then using the string name that we get from our get name P. And so that was using our old API where we pass it a string name and we're expected to know the correct type. Now, our struct earlier has tied those two items together. So P has all that information about the correct type and the name. And so we get this value out V. We assert for good measure, just because who knows, someone might have wrote a bug in the underlying system and it's not actually working like I'm claiming it's working. But we don't care if we don't hit that in our release testing because we really never expect to hit that assert, and we'll just return this V, not worrying about undefined behavior because it's going to be our correct type. Set is similar. The internal property holder returns a bool for success. We assert on that in case there's any bugs, but we know that our outer set property is only going to call get property with the types that we've paired up with that name and string in the struct. But there's one other thing we might want here, which is to actually know what if the property list actually has that type. For example, you might have a button that has a bunch of properties and a slider that has a bunch of properties, and you might have like a sensitivity value on the slider that doesn't make any sense on the button. As written here, you could pass that in and that's actually when the success would fail because, button doesn't have a sensitivity parameter. So we can put a static assert there to block it at compile time, and we're going to want to have some way to say, okay, does this property list have this type? And that looks something like this. Sorry, the indentation. Oh. I think that was a scratch space slide that snuck in. I'm sorry about that. So this is what it looks like is this property list has type, calls this detail const expr function. And this is one of the kind of neat modern C++ tricks is using the fold expression, which is these kind of 3 dots. So you see we have this property list L gets passed in and it gets unpacked into this LTS with the type name ... So now we have this list that we've unpacked all the types inside our property list. And then we pass that into is same to see if T and the thing in the list is the same. And we're going to OR that with ... which means call is same T on every one of the types in LT and OR them all together. And if one of them is true, it's in the list. just for fun, or maybe not fun, this is kind of what that is same type is type in list would look like without the full expression. If you were in C++ 14, you'd have to basically write it as a recursive function where the base case of an empty property list returns false. And then for every item, we're pulling off first items in the list. And if the first one's true, return true. If not, recurse. And that generates a lot more templates and is slower to compile. And it's just not as pretty to look at as this is. So back to has properties, this is what we have for getting and setting properties. But to get into the cool stuff, and I'll kind of go over this briefly, but is actually how do we create the properties to make sure they all have the correct types. So in our constructor, we're going to make sure that our derived class, oh, sorry, that U is a typo. It should say derived where it says U. Last minute change, I figured the U's would be complicated for everyone. But we just want to make, obviously our passed in derived class, we want to make sure it's actually a base of us. And then we're going to call this create properties, constructing our property list type. So this was the PS here is button properties : list. And you see we pass that to get this private create properties below. And that again has a variadic template parameter pack. So we see that P gets expanded, and so now we have all those properties in that list. So what does this create properties do? Well, it just calls create property with each one of those P's we've just expanded. And then create property actually does our old school property holder create property. And again, using the same stuff we built up before, we're going to get the name out of P. So in this case, it might be text, in the case of our button text. And then get name on the property type to say stood string. We want to pass, to create our button text property, we want to pass text, stood string, empty string as the default value. Now you might see default value has the same problem as name. What if we wanted a function instead of a constant member to describe the default value? We can do that as well. Get default value P. And this is exactly the same thing as the get name, except find and replace default value for name. And has default value, same trick we did before to write our type trait. And here's where the real magic happens to how we automatically connect up all of the property signals so we get all of our did set notifications, is this connect did set. It's not an actual separate method in the real code, but breaking up for the slides is a bit nicer. So connect did set is going to get this property signal, and it's going to call connect, and it's going to pass in a lambda. We're going to cast ourselves. Oh man, I swore I found all these examples. Assume U and derived are the same thing, but essentially we want to cast to the derived type so we can call methods on it. And the things we want to do is we want to call did set, passing in the P, because that's how we overload for the did sets for different property types. And then we also want to call set needs layout, set needs display to make sure nothing gets screwed up for our users and they're always getting nice updates. But what if you don't have a did set? We can at compile time have an if const expr has did set and only call that did set function if our derived class actually wrote a did set requesting that notification. And that looks like our has name, but it's a little bit different because it's checking for a instance member variable, not a static member variable. And so the way what that variation is we use declval to say, hey, imagine you have a type T, call a did set on it with a P. And if that is a valid expression, the has did set is true. So kind of similar, the only difference is having the declval to get a kind of pretend instance to use in this expression instead of the T colon we did for the static member. And also, you might not want to, for performance reasons, like if you have some property like some like binding to a data controller or something that might not immediately cause a repaint or something else, we can actually selectively call set needs display and set needs layout by having an is layout property or is display property type trait. And so how might those work? Because we didn't cover that before. We didn't say anything about that when we initially created our properties. Well, we just make a bunch of tag types. So we have a struct layout property. We have a struct display property. we have a struct UI property that is both layout and display. And essentially, we can use these to, any of our properties we create can inherit from them, and that tells the system, oh, when this property changes, you got to redisplay or relayout. And we actually tell users, use UI property as your default basically all the time, and you'll have the behavior you want. And only when it actually matters as a performance thing that you don't want to do that, you can change it to layout property or display property as needed. And the type traits for isLayout property and display property are really simple. They're just a context for bool that's the value of is base of layout property T or display property T. And so you see, we can now apply this to our properties from before, making text a UI property, so it'll automatically lay out and redraw anytime it changes. And then display, background, border color, and border width are all display properties, which will automatically trigger a repaint. Now, as an exercise for the reader, or you can just look in the library, there's another check you might want to do for set needs layout and set needs display. What if you want to use these properties on something that isn't a glass view, but you have some other object that doesn't have a set needs display or set needs layout? You could again have a has set needs display that works the same way as our has did set, and so you would only call set needs display if P is a display property and this actually has a set needs display. I couldn't figure out a way to make it look nicely on the slides, but you can do that. And then the kind of final optimization is if all of these const expr blocks are false, then this lambda we're passing in isn't going to do anything. But it is going to get fired by the system, and that will take a little bit, not much, but it'll be some overhead, might make some noise in the cache. So instead, we're going to wrap that whole property signal connect with another if const expr, just check any of the stuff we checked inside. So if it has a did set, or it is a layout property, or it is a display property, then we need some kind of signal, and then that would allow us to get into the internal one here. And that is how that's kind of the whole system for how we kind of automatically create the properties and connect them up as necessary. And that all happens behind the scenes at construction time. And then you only have the get property and set property available to you in this kind of simple API of the property holder. And you see in this last example, I showed how you can extend it a little further. What if you don't want to use this property holder type? You can actually have something else that matches the concept of property holder and template this on property holder. And so you could have your own property holder type, and it might have a type that it's did set token for the trackable. So the trackable type and the property holder could be some new construction of yours. And that I didn't write this out in the actual concept notation. Well, I did. And so I have not actually compiled much with C++ concepts from C++20. I didn't want to, I wasn't sure if I was lying on the slide. So instead, I'm showing an example class that would satisfy this concept, where it has a did set token, create property, get property, set property, and connected set. And you notice in this concept, it actually doesn't return the optionals, because in this upgrade, we're saying, actually, in has properties, we're not going to assert anywhere. It's part of the contract of property holder that the type inside won't change. If it does, you're not a valid property holder. And so maybe internally on your implementation of this concept, you might have some asserts, but we don't do that anymore. And then finally bringing us back to where we started, this is what it kind of looks like for a button declaration, where we, instead of declaring all those structs, this is the one place where we use macros. I think I could do this with templates, but was in a rush and never gotten back around to that, but I hope to someday. But essentially, this expands out into all of those structs, creating this button properties namespace and all of the properties. And as you see here, there's no strings with the names of the properties, because this macro will actually turn border color also into a string for the name, but you could optionally supply that. And then, as you saw before, we inherit from has properties buttons, properties list, and all of these will call set needs display. And then button, in addition to calling set needs display and set needs layout, because it's a UI property on text, you'll also call automatically our custom did set method. And let's see, is there anything else to tell about that? Oh, yes. We don't always use this macro, because sometimes it's actually useful to build out the structs, because I didn't put examples in the slides, but you can then do further meta programming on those structs. So our actual button class, things like background color and text color, aren't single properties, but those exist for many states of the button, because the button could be active or it could be inactive. The mouse could be inside the button, it could be outside the button. You could be pressing the button, you could be not pressing the button. So we actually take the Cartesian product of all of those states and make a color property and a image property and a text color property and a border color property for every one of those. So if you look at the library, it's property list meta has all these kind of tools for doing fun stuff with kind of dynamic meta programming your properties. So thanks for coming on this adventure with me. I hope you enjoyed it. I hope it wasn't too intense code slides for the end of the day. Into checking out the library, it will be here, like I said, as soon as I figure out what's wrong with my filter branch script so I can put the Apache license on it. So legal is happy with me. And there's my contact information. Also just want to admit, it's been a little bit tough to pull this out of our code base, so it doesn't quite build yet, but it will over the next few days. I'll get that running. I'll build outside of our environment. My email is here and on the README. If you want to email me for updates on when it builds or other updates to Glass as we release more parts of it, you can join the artisanal mailing list. So that's all I've got, unless there's any questions from anybody.
So when you were, I guess I would potentially call this a refactor, where you were refactoring from an old system to a new system. Did you have any testing in place, either pinning tests or unit tests or anything like that to verify that the functionality was still the same?
Yeah, so there were some tests where we were, like with this property system example, we have some tests where we were using the outside API and then also interrogating the internal property holder for its values. Because actually, in our system, we have a friend class that can see that internal property holder. That's what allows the interactive design tool and the serializers to interact with that. And so, yeah, we would actually, make sure that this stuff, from the outside of using this, it works how we expected, as well as the internal property holder still is working as we expected because other systems were still using that part. Any other questions? Well, thanks for listening to my tale. I hope everyone has a good evening and rest of the CppCon. If you're interested in, you didn't get quite your fix on real-time audio, Timur is doing a talk on Friday about the standard library in real time, and that's coming from an audio background. Also, somewhere in Discord, Chris Apple has been putting together trying to organize, maybe I think 6 or 8, there's a poll, a get together of people to talk about digital audio. It's 8 right now? Cool. Thanks, everyone.